So looking at first the deriving our trig functions, with this one you can either use the chain rule or you can do the shortcut. Most of us are probably at the point where we can do the shortcut. The shortcut simply taking the derivative at the front and applying our change to our trig function. This would become 4 cos 4x, and then we have to think, is it positive or is it negative? And the way we would determine that is by looking at our function and asking, does the tangent start positive or does the tangent start negative?
Positive.
Positive, so therefore it should be positive 4. Or you could look at your formula sheet. Do I need to show you the chain rule for that one? Are we good?
Chain rule.
Chain rule, okay. We're going to get y equals sine u, where u equals 4x. du dx equals 4, dy du equals cos u, dy dx equals dy du times du dx, which equals cos u times 4, which equals 4 cos 4x. Sweet. Again, we could use the shortcut here if we're really good, because it'll simply be the derivative of the inside, which is 2x, so dy dx should equal 2x cos, x squared minus 1, I've forgotten to do something. Cos needs to become
Negative sign.
negative sign. And again, we apply that same thing where I'm just going to do this one on the red. If we look at the tangent of that graph, we can see that it starts off going negative. So we know that it's going to become a negative sign. Cool? That's how I remember it. I physically draw it. Again, if I want to use my chain rule, very similar process. I might rub some of this out. I want to use my chain rule, keep everything where it is, but just change some of the values. So here I get y equals cos u. Oh, this is for this one here. I'm just doing this one with the chain rule. U equals x squared minus 1. dy du equals negative sine u. du dx equals 2x. And then we just go through negative sine u times 2x, negative 2x sine u. Oh, not u, it's now x squared minus 1. Sweet. Same process, use our chain rule. For the last one, probably a little bit trickier. We definitely can't just use a shortcut here. We need to use one of our rules. Which rules should we look at using?
Product.
We could use product. Let's go with the product rule version. Happy with that? I don't need to keep that up, I can get rid of it. For the product rule version, I should first represent my equation as y equals cos 4x cos 4x, u equals cos 4x, v equals cos 4x, u dash equals negative 4 sine 4x, v dash equals the same thing. Sweet. dy dx equals u v dash plus v u dash. Make sure we're showing our working for this, because if we make an error along the way, at least we're getting some marks for using the product rule. And we would get cos 4x times negative 4 sine 4x plus cos 4x times negative 4 sine 4x, and we get negative 4 sine 4x cos 4x plus negative 4 sine 4x cos 4x. Can I collect like terms here? Yes, because the things inside the brackets are the same and I've got the same number of coses. signs, so it becomes negative 8 cos 4x, doesn't matter the order, sine 4x. Sweet. If I had done the chain rule, do you want to do the chain rule? You're all good? U would equal cos 4x, y would equal u squared. You get 2u times the derivative of cos 4x, which is negative 4 sine x. So you would get 2 times negative 4 sine x times cos 4x, which is the same as that. Cool? So you can use either rule there. Very good. Happy with that? No dramas, we all got that 100% correct, and we can all derive trig functions.